In this session, we'll take a look at Chapter 8 objectives. We'll take a look at the intersection and union of sets. We'll also take a look at interval notation. We first see the terminology and the mathematical symbols for the union, which is OR. We also see the mathematical symbol for intersection, which is AND. In this example, we have two sets, set A and B. We're asked to find A intersect B, and we're also asked to find A union B. From our given definitions, the intersection is AND, so we want all of the elements that are in both set A and set B. So for our set A intersect B, we have the elements -1, 0, and 5. We're now asked to find A union B, and from our setup, the union is OR, so our elements can either be in set A or set B, so we'll simply combine all of our elements into one set. We have the set A union B is -10, -3, -1, 0, 2, 3, and 5. Next, we'll write each as a single interval. So we'll graph each separately, we'll analyze the graph, and we'll determine the union. So for our first graph, we'll center it at about 7. I'll put -infinity to the left, +infinity to the right. At 7, our symbol is a parenthesis that faces the left. Our line also extends toward the left. For our second inequality, the open interval from -infinity to 10, I'll draw another graph. I'll center it at about 10, -infinity to the left, +infinity to the right. At 10, our symbol is a parenthesis that faces the left. Our line also extends toward the left. We want the elements that are in set A or set B. So our solution is the open interval from -infinity to +10. Next, we'll take a look at the example, the half open interval from -infinity to -3 intersect the half open interval from -10 to +infinity. So once again, we'll graph both separately, we'll analyze the graphs, and determine the intersection. For our first graph, we'll center it at about -3. We'll put -infinity to the left, +infinity to the right. At -3, our symbol is a bracket that faces the left. Our line extends toward the left. For our second inequality, the half open interval from -10 to +infinity, we'll center our graph at about -10. -infinity to the leftmost, +infinity to the rightmost. At -10, our symbol is a bracket that faces the right. Our line extends toward the right. We're asked to find the intersection. We want all of the elements that are in both the first set and the second set. And that appears to happen at negative 10 to negative 3. So our solution here, we have the closed interval from negative 10 to negative 3. Now we'll give the solution set in interval notation. In our first example, we have the inequality x plus 3 is less than or equal to 0 and x plus 1 is less than or equal to 9. So we'll solve both inequalities for x, we'll graph, and we'll determine the intersection. We solve our first equation for x, so we subtract 3 from both sides. X is less than or equal to negative 3. To solve our second inequality for x, we subtract 1 from both sides. We'll now graph each inequality. So for our first inequality, we'll center it at about negative 3. Negative infinity to the leftmost, positive infinity to the rightmost. We want all values for x that are less than or equal to negative 3. So at negative 3, our symbol is a bracket that faces the left. Our line also extends toward the left. For our second inequality, x is less than or equal to 8. We'll draw a graph. We'll center it at about 8. Negative infinity to the left, positive infinity to the right. We want all numbers that are less than or equal to 8. So at 8, we have a bracket that faces the left. Our line also extends toward the left. Here we ask for the intersection, all of the elements that are in the first set and in the second set. And that appears to happen here toward negative infinity and also here at negative 3. So our solution is the half open interval from negative infinity to negative 3. Next, we'll take a look at the last example. X plus 1 is greater than 5, or negative 4x plus 2 is greater than or equal to 6. So once again, we'll solve both inequalities for x, we'll graph, and we'll determine the union. To solve our first inequality for x, we'll subtract 1 from both sides. So we have x is greater than 4. For our second inequality, we'll first subtract 2 from both sides. So we have negative 4x is greater than or equal to 4. Next, we'll solve for x by dividing both sides by negative 4. You want to remember that when dealing with inequalities, whenever you multiply or divide by a negative, you must reverse your inequality. So we have our two inequalities, x is greater than 4 and x is less than or equal to negative 1. So we'll take our first graph, we'll center it at about 4. Negative infinity to the left, positive infinity to the right. We want all numbers greater than 4. So at 4 we have a parenthesis that faces the right. The line also extends toward the right. Our second inequality, x is less than or equal to negative 1. So we draw a graph, we'll center it at about negative 1. Negative infinity to the left, positive infinity to the right on a graph. At negative 1, our symbol is a bracket and it should face the left. Our line should also extend toward the left. Here we want the union, so we'll combine our sets. So So our final answer is the half open interval from negative infinity to negative 1 union the open interval from 4 to infinity.